All right, so we're recording. Let me unfree. Oh, actually, let me go to the. What? It's not working. There we go. All right, now we're. All right. I hope that's recorded. Yeah, I think that's. So when we find the slope, if we do not have a graph, we do the whole y2. Again, that's the formula for slope over there. I will keep it up for the quiz, so you don't have to worry about memorizing it. You will also get the distance formula, which is the part that comes after this, although I'm going to show you a different way to do it, which I've already shown you before. All you need to do is label the points. I mean, after that, it's just really plugging numbers into the right spots. And the ones and the twos don't mean you're doing any math. It just means I'm calling that my first point. So this is all review, by the way. If you weren't here, you're getting a quick version of the lesson. And I'm calling this the second point. That's all the ones and twos mean. They don't mean do any math. They're not like squaring a number or anything like that. I just need a way to say, tell me which x is the first x, which x is the second x, which x is the first y, which x is the second y. So the formula, which I would write down every single time I did it, I wouldn't just, you try to look at it on the board or even just write it once on my paper. I would do it every single time I did a problem, because otherwise some people will mess up. Guaranteed, it happens every year. Sometimes it's even people that are pretty good at it. Now I can plug numbers in and they're right where I need. So I need my y2 number, which is what? Anybody else do it number that like do the points differently? Did anybody make this x2, y2? Figured everybody would do this. It doesn't matter which way you do it. If this would have been x2, y2, and that would have been x1, y1, you'd still get the right answer. There's no order you have to do the points in. So what you do need to remember is the subtraction sign is part of the formula. Always write the subtraction sign. Then, if the next number is negative, write the negative in front of the number. In this case, it's not, it's just positive 1. Down here, we say, all right, my x2 number is what? 2. Again, write the subtraction number. Stefan, what do I write now? What do I do now? Last thing, you just got to finish it off. -4. Just because I wrote a subtraction does not mean I get rid of the negative sign. Guaranteed somebody's going to do that. So what you get is your final answer, sort of final, -4/6, but you have to simplify. Mainly you have to simplify because when you compare slopes, like when we did the part before that will be on your quiz is on Thursday, you have to tell me if lines are perpendicular or parallel, and that's the way you do it. You have to compare the slopes, and if you haven't simplified the slopes, you're not going to be able to compare them correctly. So just make sure that you understand how to simplify a fraction. That is step 1. We are done with step 1. Step 2 is easy. There's no math. I mean, there's no math in it. How do I find the perpendicular slope to a line? Basically, perpendicular slope to that slope I just figured out. How do I do that? So there's no and 2 flips actually. Right? I got you. So Kai certainly gave us part of it. So the way that I'm going to try to help you remember, because this is not anywhere, like this is not on a formula sheet or anything that you're going to have to memorize this. If you need to take the slope and make it the perpendicular slope. So what that means is this line that we created, there's a line that goes through those 2 points. Like if you put 2 points on a graph, you can connect them and make a line. There is a line that is perpendicular then to that line. We could create a separate line perpendicular to it. That perpendicular line would have the slope that is the perpendicular slope to that. That's what I'm saying. You'll see it when I do a graph of it. So in order to do that, here's what I want you to think. The perpendicular slope has two flips to the original slope. We're going to flip the fraction, the numbers. That's the first thing we're going to do is flip the numbers. The second thing is we're going to flip the sign. So let me do this a different way. So that was a negative 2/3. So I want to make it a positive 2/3. No math involved. You flip the numbers top and bottom, and then you flip the sign to the opposite side. Do not just do this. And it just now dawned on me that some people are probably going to do this. It does not mean to change it from this. I don't know how you would do it. It doesn't mean to change it to that. That's not flipping the sign or to do this. That is not flipping the sign.
Yeah, some of your kids. It's something about
Oh, your tutor? Oh, hey, this is like. I mean, yeah, that's right. Yeah, he's right here. Got it wrong. So you have to make sure whatever the original sign is, that is a negative. That's a negative. Then the flipped version needs to be positive. Just make sure if one's positive, the other's negative. You're always going to have a positive and negative slope. Just remember that. Never two negatives, never two positives. All right, so by the end of the day, you have absolutely got to be able to do this. And you're going to have several practice problems that are in your book pages, which you'll get out in a minute. Any questions on this part before I go into what I do see as being a little tricky? This part shouldn't be tricky. All right. So now let's yeah, we'll use this. I forgot I had this, to be honest. I'm gonna redo the whole thing, sort of. All right, so now I've put the 2 points on the graph. I believe that's where the 2 points go, right? Where the points -4, 1, and then 2, -3. Are those the two original points? Yeah. All right. And then the point they told you to get the parallel line was 1, 2. They're taking it to C3. Oh, speaking of which, I got to give stuff out in this month. I'll do that when you do your individual practice. Remind me. So I've put the points on the graph. What they're telling you to do is to draw a line between the 2 points. So there's your line. So that's their first step when you're doing the whole process, meaning you're going to find the distance between that point and that line that we just drew. So what you need to do is you need to take that perpendicular slope. So the original slope was this. The perpendicular slope was this. And you need to create a line with that slope that goes through that point, and it will intersect that line. I decided I'm not showing you the more difficult way to do it. The way that you have to like create equations and take values and plug it. I mean, she's teaching it in the other class. I'm not going to teach it. It's a lot. It's a lot to teach, and it's a lot to try to remember to do. I'm hoping that we can get away. And I checked every problem in the book. This works for every problem. I'm hoping that will be the case for district stuff and the EOC, the midterm. I need to make a line that goes through this point and connects with this line, and it needs to have this slope. This is the perpendicular slope that I came up with when I flipped everything. So here's what we said. So now's where you need to focus. It's the tough part. I just need to follow that slope and get to that line. A little bit of a problem on this one because if this is, and so you're going to use rise and run when you do this, by the way. Rise is the top number, run is the bottom number. What direction is a +2 for the run? Remember that? Which way? +2 run is which direction? Hopefully you know run is left and right. So it's right, correct? So I'm going to go 2 to the right. So I'm going from the point that I'm trying to connect to that line. Which way is a positive rise? Rise, hopefully you know, is up and down. If you don't know that, you need to refresh your memory. Positive rise would make sense to go up, right? I'm going to go up. What's the problem with that? Am I getting closer to the line if I go that way? Right. So what do? What do you mean backwards? You would reverse both of them. You can say, okay, well, if that's not getting me closer to the line, I need to reverse both directions. So instead of going right 2, go left 2. Instead of going up 3, go down 3. That, as you see, not only gets me the line, but it lands me exactly on a point where I can figure out the X and the Y value. And that's what we need. We need to know what is the X and the Y value for that point. If I would have landed in between, like somewhere in here or like in here, it would have made it kind of difficult. Every problem in the book, though, lands right on a spot where you can clearly see what the X and the Y are. What else could I have done besides reversing the direction? You forget that. Every other class got it. What else could I have done? If I created these 2 points and I'm like, wait a minute, I'm going the wrong way, and I forget about the reversing thing, what else could you do? Need a line that's going to connect to this other line down here. What? No, you don't need to start. You got everything you need. Before I even did the green stuff, you really had everything you need. You didn't need to really reverse direction. Reversing direction is probably actually the best way to do it. If you forget that, this will typically draw a line through the other 2 points. Just take a straight edge. Make sure you go right through the 2 points you created, really right through the corners. There we go. If I put a line through those 2 points that I created, it's not right through them. Make sure it's like as perfectly as you can do it. Make sure it goes right through the corners of those squares. You'll see it hits that line right where I hit the line doing the other. So you can just draw a line. So either way, if you use them and you can't figure out how to get back to the line, then just put the points where they should go and draw a line through them. Or if you remember, just reverse both directions. Regardless, hopefully you're going to hit on a spot where you can clearly say the X and the Y is that -1, -1. And that one they had given us was what, 1, 2. So now you have your 2 points. You need to do the distance between those 2 points. You have the distance formula on the reference sheet. So you could label, it doesn't matter which one, label one of them X1, Y1, one of them XY or X2, Y2, plug them in the distance formula, and that will give you the distance between this point and that line. Oh, distance, by the way, remember, that's the definition of distance, is it's the distance perpendicular to the line. So we wouldn't measure distance by going straight down like this. That's not perpendicular. This point going straight down is not perpendicular to that line. We want to measure the perpendicular distance because that's the shortest distance. That's what distance means, we said. The shortest distance is what we want when we say the distance between a point and a line. I'm going to show you the other way. If you're already graphing it, which you will be graphing it, they give you graph paper on the EOC. I'll give you graph paper. If you've already graphed all of this, I would not do the X1, Y1 thing. If you have this point right here, if you know it's connecting right here because you counted, either you drew the line or you counted or whatever you did, but you know this is the distance you want, just create, and we've done this before, some of you got it, some of you didn't. If you don't get it, then do it the other way. This is a triangle right here. It's a right triangle. Let's do that in another color. There. That is a right triangle. I went straight left and straight down. That creates a right triangle. Sometimes you might go right and then up. It doesn't matter. You're creating a right triangle every time. You already know the length of those sides. That's a length of 2. That's a length of 3. You just counted them. That's how you got them. So if you know the right triangle is set up like that, there's no need to plug in x1, y1, x2, y2. You have, this is all x1, y, x1, y1, x2, y2 is going to get you. It's just going to get you those two numbers. So if you just create that triangle, a little bit larger so it's easier to see. When you go to solve for this side, that side is C. It's the missing side. It's also the longest side. It's the hypotenuse. So the formula for a right triangle to figure out a missing side is that a squared plus b squared is c squared. We know a and b now. They're just the length of those two sides. So we would say 2 squared plus 3 squared equals c squared. Again, doing the x1, y1, it'll get you to this point right here. It's just more work. But you'll have the same exact, eventually you'll get the same exact thing there. Now you get 4 plus 9. The only tricky part about this is you'll eventually get to this if you do this method. Here's where you might have to use a little common sense or just memorize the last step. That is clearly not a length of 3. I hope you don't think that's a length of, I'm sorry, a length of 13, because that's what I came down to, right? I got 13 equals c squared. 13 is from here all the way to here. That would be how long 13 is. That line's not that long. So that cannot be the right answer. Don't get down to a big, big number when you have two small numbers here and then there's a huge number there. That's not the end of the problem. That's the one mistake that I see people making over and over again that do it this way. I need to take that last number, and really I also am technically taking the c squared part, and I need to take the square root of it. That's what c is. C is the square root of that number. Technically, we're taking the square root of c squared, which just gives us the c, but just remember this can't be the right answer because that number is way too big for that try. Just look at the triangle. You can see how long the line is approximately. It's approximately 1, 2, 3, and a little more than 3. If this was 3 here, this is just a little bigger than 3. That's the way I would do it. If you want to do the other way, that's fine. Doesn't matter. But that's how you do the distance between a point and a line. You have till 103, so you have like 20 minutes, more than 20 minutes to practice. Did I miss something? I feel like maybe I missed something. If you don't have the pages with the lesson as well as the problems you're going to do, or these pages, the problems are on page 215. And then the example, I don't know what page the examples are on, but we just did it. So you have an example already done for you. I'm going to put them up on the board too. I'll probably want, oh, I know what I haven't shown you yet. I'm going to go ahead and show this to you really quickly. Go ahead and graph the stuff first, because some of them turn out to be really easy. When you graph the line, some of them turn out to be a straight, flat, horizontal line, and then they give you a point somewhere, like here. How do I do a perpendicular line to that? You graph a horizontal line, flat line, and then you have a point. How do you create a perpendicular line to that? And you just go straight up, right? If you have a flat line, perpendicular then would be straight up and down. So the distance is just 1, 2, 3, 4. You don't have to do any of that other stuff if you graph it and it looks like that. Then you're also going to get one that looks like this. If I have a line that looks like this, and the point over here, how do I create a perpendicular line between that point and that line. Straight left and right. So I would graph first because you're going to see that graphing will find you the distance faster on some of them because all you're going to do is those things right there. You could still, well, actually, one of them you almost can't even do. It's technically a line that's vertical has an undefined slope. You can't really solve for the slope, so you may have to do them that way. I don't know. And then these are the problems here. If you don't have your pages, I'll put all the problems up in a minute. There's 6 of them, but that'll get you started right there. I don't think I can fit. I don't think I can zoom in anymore and still fit all. Oh, I went the wrong way. There, I guess that's not, hopefully you can see, if you can't see that, you can move closer. It's page, bless you, it's page 215 though in your book, the practice problems. There's 6 of them, not just 4, so make sure you do all 6 of them. Graph them first, create the line first on the graph, see what the line looks like, then put the point on the graph that you're supposed to figure out the distance between the point and the line. And 3 of them are actually pretty easy. This one's easy, this one's easy, and then number 6 is easy. You don't really have to do the whole process for 3, 4, and 6 if you graph it out. I'm going to do number 1 for you without a little more than 5 minutes left in class, just so you can kind of check and see how you did. Today is your practice day, and then tomorrow is your practice day. And that's practice for everything, not just what we're doing today. There's at least 3 major topics on this quiz. This is on there. Doing when we did perpendicular lines in a transversal, that's on there. And we're going to do the distance between 2 parallel lines also, but that's really the same thing as this. We don't have any extra books for a page. Did you have a page? Oh, you're not here. Any of the days where we use a page.
I do, but not too.
Do you have from 191 to 224? What do you have? Don't have them, you have to write down the. Use them on page 215. Where else? You left them in here or something. You had to have had them. Oh, yeah. So again, if you didn't hear what I said, you're doing 1 through 6 on page 215. And I did what we just did for bell work, and then the rest of it was exactly what you're doing for all 6 of them. You'll get a little practice time, well, a little today. Tomorrow, you're going to have a lot of practice time, and you're going to be practicing a whole bunch of things. So don't waste today just because you think phones should not be out. No reason phones should be out. No Excel today. I probably do somewhere, but you just want to do a straight line, right? Yeah, if you want a straight edge, I'll give you an index card. Those work pretty well for just doing straight line. It connects good points. And you can use anything. Use the edge of a pencil. I used to have a bunch of. Oh yeah, here they are. If anybody wants an index card, I have some index cards I can give you for doing a straight line. Exactly. Exactly the same. So what you better be able to do, like I said, by the end of the day, figure out the slope of the original line, and then what is the perpendicular slope. That's an absolute must. You can't do that by the end of the day, you're in trouble. I don't see how you're gonna pass the quiz. Not this one. Oh, oh wait, I'm sorry, no. You're, you have questions, today's day, don't sit there, I know it's first day back, but we don't have time to take a break on a day this fast. We're way behind everyone. Not sure we're ahead of anybody anymore. Used to be at least even. Oh, I'm gonna stop the. Actually, I'm gonna keep recording because I'm gonna do number one for you in dead space. Carlos, that's not practicing. Come on, focus. Go back and see what's on the quiz. Definitely parallel lines and transversals. It might be the only one to take. So you'll have to name the angles. You have to solve for variables. Let's start by showing me the function. So this is not one. Something. That'll probably make it look a little.
Bill,
No,
but no, it's supposed to be.
not just hear me say if you need an index card to make a straighter line, I'll pass them out. I walked around, crossed them out.
But like,
Luckily, you were talking about that. Again, don't focus. What I would do, in all honesty, is I'd make really tiny lines. Well, you can't say that's one. You can't just say, oh, that's just one. One would be. What you gotta know is that, are you positive that's the perpendicular direction? First, you gotta find out where is the perpendicular direction. Intuition is good, but you need to go through. So what is, you gotta figure out the slope of the original line. So what's the slope between these 2 points? Oh, I didn't tell you this. Once I had graphed the line, by the way. I'm gonna go back to the page before, I think. If you've already graphed the line and you want to figure out the slope, because you're graphing the line first in those, don't forget, you can just do the rise and run thing, like count left or right and then up or down. So you can figure out the slope that way also. That if you've already graphed it, that's probably faster than doing the x1, y1, the whole y2 subtract y1 thing. If that doesn't make sense, then just do it the x1, y1 way. But if you're already graphing it, just count from the left point, count right, and up or down, and that'll be your slope. I'll come back there, Hannah, and Elijah. So that's the original slope. So what do you need to do with it? Now you need, so the second step is perpendicular slope. So what do you do? So you flip it twice. Flipping it once really doesn't change it, right? You start 1 over 1. What do you need to do from there? Flip it, and it's still 1 over 1, but you need to do what? So what would it be? So positive 1, the perpendicular slope is just negative. Yes. Probably should check. Good. Was it about that same? It's practice day. No one. What? Right. So what would we do to that? It's the second step.
What's the answer?
Well, you need to go through the whole process. That's an easier one to see, but you still need to go through the whole process because the other ones, the ones on my quiz won't be that easy, and I guarantee you the ones on the district. So the original slope is 1, or 1/1. You need what for the second step? You didn't write those steps down, you should have. First step, find the slope. Second step, find the, what's the second step? What do you do once you found like the original slope of the line they give you? You need what? You need the perpendicular slope. That's your second step. So what's your perpendicular slope? Well, I just did all these steps. Figure it out. You have a lot to learn tomorrow. There's a lot of math. Really just 2 topics, kind of 3, but really just 2. I'm going to do it in a minute, so if you're not following it, make sure you write the steps down when I do it. Round it. 1, 1. 3, so I'm going to do it in 1 minute. There's kind of 4 steps to it. You didn't write down those 4 steps when I just did it. You better write them down when I do the next one. There, wow, it's not. Structure. Plane and yeah, yeah. Wow, pretty cool class. All right, so I'm going to do number 1 super fast. It'll be recorded though if you don't follow along. Kind of already done it. All right, so actually, I guess I'm going to have to redo it. What are the points? Give them to me fast. The 2 original points were what? 7 and 7. 1, 2, 3, 4. There's that point. What was the other one? 0, -3, right? So there's the 2 original points. That's the first thing you do is put those 2 points. They form a line. So you connect them and make them into a line. Now you take the 3rd point, because that's the one you want to figure the distance out. 1, 2, 3, 4, 3. Is that right? 4,3. So there's that point. You want to know the distance between that point and the line. You can't just say it's 1 because that's not a distance of 1. 1 is from here to here. That's a distance of 1. From there to there is not a distance of 1. You can't do that. So we have to, and again, this one's an easier one than most. I need to figure out the slope of that original line. If you do the slope formula, it comes out to, you get 7/7. If you didn't get that, then you need to go back and see why. That reduces to 1/1. That's your slope of that line right there. Bones should not be out. Because if you didn't do anything, which pretty much none of you did, because I don't think I had anybody that probably finished this out, you need to flip the fraction and make it negative for the perpendicular slope. That was step 2 that I did. You need to be writing these steps down. Step 1, find the slope. Step 2, find the perpendicular slope. Step 3 is the trickier step. You need to use that perpendicular slope and work your way back to the line. Or just draw a straight line somehow connecting the dots. In this case, if my run is +1, oh, I knew that was messed up. I'm going to have to kind of improvise. Let's see if this works. My run is +1, so I go 1 to the right. My rise is -1, so I go down 1, and that puts me right on an X and Y value that I can easily see, which is what we want. So for those X and Y's, this is going to be so far off, but I don't really have a choice. That is, this one up here we said was, fixed itself, 4,3. This one down here would be 5,2. You can now figure out the distance between that red point and that black point, which is the distance between the point and the line. Use the distance formula, x1, y1, x2, y2 if you want. I'm going to tell you the fastest way, though. You just counted right and then down. That's a right triangle. Use a squared, b squared, c squared. The right triangle has a side of 1 there, a side of 1 there. We're going to solve for that side c. So your formula, a squared plus b squared equals c squared. So we're solving for the long side c. 1 squared plus 1 squared equals c squared. 1 squared is just 1. So if you go through and you do all the math correctly, regardless of which way you do it, you should get the distance between that point and that line is the square root of 2. Or if you wrote a decimal, probably 1.3 something, I think somebody said. So that's the entire process. Step 3 is this process where you work your way back to the line. So this was step 3. Step 4 is this process over here where you figure out the distance between that point and that line. Or you figure out the longest side of that right triangle. That's what's going to be on your quiz. So you need to, and that's not the only thing. There's actually 3 topics. So you're not going to have all day tomorrow to practice just that one thing. But I guarantee you don't remember how to do some of the other stuff that we did before that.